Hey, my name is Josh Garrick. I'm going to going over an intro to chemistry with the periodic table and atomic structure today. So, the first thing I guess we should go over is protons, electrons, and neutrons and how they make up the atom. Basically, all matter consists of particles called atoms. And inside an atom, you're going to have protons, electrons, and neutrons. This is the basic chemical structure of a helium atom, which has protons and neutrons making up the nucleus, which are surrounded by two electrons. And the relationship between these protons, electrons, and neutrons is listed here. You have neutrons, which can be given by a number n, the atomic number, which can be given by z, which is also the number of protons, and the atomic mass number, which can be given by a. So in the periodic table, you're going to have them set up not like this, but you're going to have the atomic symbol with the atomic number as well as the mass number, and with that, the atomic mass number will always equal the number of protons added to the number of neutrons. Okay, so now looking at the periodic table of elements, the periodic table is split up evenly so that we can see clearly the different elements and how they are related to one another. Going up and down in the periodic table, you're going to see all of the different groups, and going left to right, you're going to see the periods of elements. This first group is going to be the alkali earth, or the alkali metals, followed by the alkali earth metals. In here we have all of our metals, and over here we have all of our nonmetals. Right here from group 17 we have our halogens, and on the very end we have all of our noble gases and rare gases. Okay, going back to what we were discussing before about the periodic table and atomic structure, we have two different ways you might see an element written. Over here you have a way that it could be given on a test or in any book with the carbon atom, and here's how you'll see it on the periodic table. We have the atomic number of 6 and the mass number of 12.011. In this form it's just rounded, but this is how you can see it just transposed in different ways. But the relationship is still the same, with the atomic number of 6 being where you would find it on the periodic table, while that is also the number of protons as well as the number of electrons. Unless it's charged, they're going to be the same, while 12.011 is the atomic mass number, which is the number of protons added to the number of neutrons. So in seeing that, you would see that the number of neutrons would also be 6, because 12 minus 6 is 6. So the number of protons, electrons, and neutrons in the carbon atom is all 6.